But how do you know, looking at table I, if this, for example, is exothermic? Because what Steph just said, this is on the right, so I'm thinking it must be exothermic, but how do I know?
Because of the negative, right?
The negative, right. So on table I, you look to the right of the reaction, and you're going to see, for this one, right, second one from the bottom, everyone should be there on table I, you should see negative 48.83. Is that correct? Yes. So it's important to understand how to read table I, and then how to write it in an equation. That was the whole point of that homework. Doesn't look like you guys had too much trouble with it, okay? How come there's no negative? That's just the rules. It's just the way it is. There's no minus signs, no negatives in chemical equations. But if I asked you, what is the value of the delta H RXN, then, hey Sarah, your answer would be negative 48.83 kilojoules. So if I ask you, or the regents ask you, test question, they give you this reaction, they say, what is the value of delta H? You gotta have that negative. The value has the negative, but in the equation, no negative. It's kind of tricky, but that's the deal. Questions? Jake, you good? You got something the right way?
Yeah. Are we doing notes?
We are gonna do notes, but hold on. What's this mean?
Water.
H2O. Why is that above the arrow?
Because it happens in water.
What do you mean?
Like, the reaction occurs in water, it doesn't occur in air.
Right, it's actually a physical process. This is what happens when you dissolve. When you dissolve this in water, it dissociates, breaks apart. The word is dissociate, which is the opposite of associate, right? Dissociate, break apart. You get positive ions, negative ions, and in the process, it releases heat. Who had lab this morning? Anybody in here? Just Sarah? Oh, Blake. So, did you guys have the one where the temperature went up or down? Yours went up? Yours went down? This one, the temperature would go up of the water because it's releasing heat. It's exothermic, so the water gets hot. The rest of you, you'll have lab Thursday. Yeah, Thursday. We'll do that. So no questions on that sheet. Everyone's good. All right, put that away. You're gonna need a calculator and take out your notes if they're not out already. Oh, Shelby, I have a sheet here for you. I still gotta give you guys that quiz back. I keep forgetting.
Can you give us that now?
Probably not.
I did really good on that.
If you wanna know what you got, you can see me after class. Oh, speaking of quizzes or tests, next Friday. I didn't write it up there, but next Friday you're gonna have quarter one test because quarter one is over. Quarter one's over this Friday, technically, but so next Friday it's gonna be a test on everything you learned in the first quarter. Probably about 35 questions, mostly multiple choice, some short answer. What we're doing today, I'm definitely gonna ask about, so pay attention.
Today is 10th.
Today's the 10th. So next Friday you'll have that test. Mostly multiple choice, like I said, with some short answer. You can. All right. So here we go. You weren't here Friday. Who was here Friday? What's the last thing we wrote?
We did the endo reaction, right?
Just one of those things?
Endothermic processes. Yeah, one of the ones that we did there, yeah.
Okay. Moving on. Here we go. Given. Write this reaction down, please. Let's go with N2 gas plus O2 gas. Sorry, there's 2 there, I think. This is one of the ones from the homework. Yields 2NO2 gas. So given that reaction, here's a question for you. You may have no idea how to answer it, but that's okay. It's why we're doing it. We'll learn. Calculate the value of delta H RXN, heat of reaction, of this reaction. Well, I guess that's redundant. Calculate the heat of reaction of this reaction or for this reaction. If 1 mole of O2 gas Calculate the value of the heater reaction for this reaction if 1 mole of O2 reacts. So just copy everything down, and then let me explain. What does value mean?
Amount.
Yep, amount, I want a number, but I also want a sign. So whenever you give me whatever the answer is to this question, we're gonna have plus or minus, and then a number. So positive or negative with a number. That's what that means. So, this does have to do with what we just went over on the homework. You gotta go to table I, you gotta look this reaction up. So everybody do that, find that reaction. And find the value of delta H on table I for this reaction. So what is it on table I? We need to know that first before we can answer the question. And Bree's going to help us. What's the value of delta H on table I for this reaction? Is it endothermic or exo? Endothermic, how do you know? Positive. So which side of the arrow do I put it on? Left side, good. Okay, so everybody write that down. 66.4 kilojoules plus the N2. It's endothermic, so it's absorbing heat from the surroundings. Okay. Does anyone think they know how to answer the question now? Here's the value of delta H. But the question is changing something. This is the change right here. That's the difference between the reaction and what the question is stating. It's not really a question. Isla, what's a mole? Or what does the unit mole mean? Oh, good. We need that a little bit later. So hold off on that for about 10 minutes.
What did she say?
22.4.
Oh, okay.
What's a mole a measurement of? Like grams are a measurement of weight or mass, I should say. Liters is a measurement of volume. What's a mole? If you don't remember, it's okay. Someone else had their hand raised. Besides, I'll come back to you in a second. Edwin, remember what a mole measures? Yeah, the amount of something. That's it. The amount of particles. 1 mole of oxygen is different than the amount of moles of oxygen in the reaction. How many moles are in the reaction?
2, right?
2. I don't know if I taught you this yet. I don't think I have. This big number in front, you've seen it because we balanced equations talking about conservation of mass. You've seen it already, but I didn't really fully explain it. This is called a coefficient. A 2. There's actually a 1 here, but we just don't write 1s. You could put a 1 there. It's just not normal. So there's a 1 there, a 2 there, and a 2 there. Those numbers stand for moles. So what does this mean? Listen carefully, pay attention. This will help you understand how to answer it. This reaction absorbs 66.4 kilojoules of heat. When it does that, 1 mole of N2 reacts with 2 moles of O2. When those react, they produce 2 moles of nitrogen dioxide, NO2.
But if there's only 1 mole of oxygen.
So, hold on. So the mole ratio of this reaction is 1 to 2 to 2. In other words, I need 1 mole of this and 2 moles of that to produce 2 moles of this. And this much energy. If I change any of those, even the heat, they all have to change. So the question is saying, what does this number change to if only 1 mole of oxygen reacts? Because 66.4 are needed for 2 moles. So what if we change the 2 to a 1? Well, we're going to have to change all the other numbers as well. We'd have to change that to a 1. We'd have to change that to a half. What do you think we do here? Cool. What would make sense? If we chop the 2 in half to a 1, And then that would be half, and that would be half. What would we do there? Make that half. What's half of 66.4? Shelby? 33.2. But instead of doing that in our head, there's a way to show it. It's called a proportion. So go ahead and copy that down. Here's how we do it. We look at the oxygen. 2 moles of oxygen absorb or need 66.4 kilojoules. So that's one proportion. 2 is proportional to 66.4 as 1 mole of O2 is proportional to X. So if 2 moles need 66.4, then how many kilojoules does 1 mole need? It makes sense to us, I hope, that if we cut one in half, we cut the other in half. Hopefully that makes sense to you. It's all proportional, but this is a way to show your work and to kind of organize your thoughts. 2 to 66.4 equals 1 to X. How do you solve for X? Cross multiply, what do you get? No. Before you get the final answer.
So you get, well, when you
get 2x equals 66.4, right?
So then you have to divide by 2 to get X by itself.
Divide by 2, X equals 33.2 kilojoules. And I'm going to be a stickler about this. Put a plus sign there. Why? Because it's endothermic. So we give a positive sign. It's endothermic. This is what your worksheet, that I'm going to give you in a little bit, is going to be on due Thursday. Just a bunch of these. We're going to do another one right now. Questions on this? Devin, you with me? Make sense? Evan, you with me? Xavier, you with me? Yeah. Jenny, you with me? Who's not with me? No one wants to say that, okay. All right, let's try another one. So I'll copy a different reaction, different question. You're gonna do the same process, exact same process. Just a different answer, here we go. Given N2 gas plus 3H2 gas yields 2NH3 gas. So go ahead, copy that down. Here's the question for you. What is the value of delta H RXN if 1 mole of H2 gas reacts? 1 mole of H2 gas reacts. So write the question down, solve it, show your work. I'm going to walk around and see how you're doing. And then we'll call a lucky person up to explain to the class how to do it. Blake, you were marked absent period 2. Does that make sense to you? Okay, just letting you know. Might want to talk to Mr. Mathis. You weren't in the bathroom smoking again? No. No?
That's why he was sick. Yesterday he was all day. Choo-choo. Chooching.
Not really. That covers it on one. So I noticed a lot of you, you're starting off with the, the proportion lines. That's good. So before you even write anything down, set up your proportion. That's good. It's a good way to do it.
Right.
You will find out. Maybe you'll be the lucky one to go up there and show us. Jake saying he wants to be one. So some of you I see don't like to use units. That's not good. Also, some of you, the rows are still all screwed up. It's 'cause I think, this row is way too far back. Or maybe Devin's a little far forward, maybe? I'll fix it. So, you need units. You need units on your answer and the sign, positive or negative. If it's exothermic, it better have a negative. If it's endothermic, it better have a positive.
Yeah, I'm confused. Do you want me to show you real quick?
Yeah, I don't know what it is.
One sec.
Who wants to go up there and show us how to do it?
I'll do it.
Alright, go ahead.
One sec. Nice
Why's
one.
your phone out?
I'm using the calculator.
Yeah, I don't want you doing that.
Alright, one sec. Let me just finish. I don't need to have it.
Make sure you show all your work and then explain to the class what you're doing.
Oh, as I'm doing it or when I'm
As you're doing it.
What are these called again?
What are what?
These things.
Proportion?
Proportion.
Okay. Alright, here we go. Ryan's got it. He's gonna explain. And you may or may not be right.
So you have to go to the table I to get the thing first, the 90.
What's the thing?
It's exothermic, so it goes on the end.
Hold on, what's the thing?
The whatchamacallit, the kilo
Right, what's that called?
is what do you mean what's it called? It was here. It is.
It's called the heat of reaction. So you gotta get the heat, you gotta find the heat, look up the heat.
I did.
Yes, and it's 91.8 kilojoules. Don't forget the kJ.
Oh yeah. Oh I did.
Why you put it on the right?
It was exothermic.
Very good.
Okay, and then I did the proportion thing.
Yep.
So I did the 3 moles of H2
Yep. Where'd you get that 3 from?
here,
Good.
and then over 91.8.
Hold on, you forgot one little thing.
I have to do the other side.
No, I know that. You got the numbers right. It's exothermic, so the actual value of that number
Is negative?
negative, right?
Okay. Negative, whatever.
Good.
And then so equals 1 mole H2 over X. And then cross multiply.
Yep.
So negative. Oh no.
You can jump right to the answer. That's fine.
Okay,
We should know how to do that at this point. So he has a negative 30.6. Don't forget your units.
There.
Very good. Good job. Good job.
I think I can teach the class. Just gotta improve my handwriting a little bit. I'd be the best teacher ever.
Do you need a college degree? So, Jake and Kristen, are we good here?
Sure.
Look up here. Ryan just explained the whole thing here, but let me go through it again. So you set up your proportion. First, you look this up though. You look this up, it was exothermic, so it's written on the right side. 3 moles came from here. So the ratio is 3 to 91.8. 3 to 91.8. It's negative, don't forget that.
It was
The
that.
question, I know. The question's changing this. Instead of a 3, it's telling us we only have 1. So So if you decrease anything in the reaction, you're going to decrease the heat. If you increase anything in the reaction, you're going to increase the heat. Whether it's endo or exo, it doesn't matter. That's how it works. It's proportional. So 1 produces X. So if your moles decrease by a third, your heat will decrease by a third, and that's negative 30.6 kilojoules. So your homework is practicing more of this, so I'm not going to do any more right now. We're going to do something a little different here in the last 7 minutes, 8 minutes or so, but still proportions, but different than this. So I'm going to hand out your homework. It's just like this. Show all your work on the back. I think it says the directions, but we are not done with notes, so do not put anything away. Okay, so this is due Thursday. 2, 3. You're not? That's unfortunate. I'm not going to be here tomorrow.
I'll be here. Except I was like, what do you mean you won't be here tomorrow?
But I won't be here Friday either.
I'll be here tomorrow.
Right here.
Hey, do we have practice? It was rushed.
Everything's okay.
I was rushing up the house, but I just grabbed them.
What is that, coffee or something? I don't know what it is. It's like dirt.
Okay, so this is due Thursday. Put that away. Don't work on it now. Now I'm going to write a question on the board. See if you can figure it out.
What? The water is pure.
Write this down, please.
I don't know.
Don't extra sorry, Charlie.
Machine or something?
All right. So, write this down word for word. Calculate the amount, the amount of space in liters that, I don't know, let's say 2.5 moles of helium gas occupies, that doesn't look right, at STP. And if you don't know how to answer this, the answer would be on the mole box. But we're not going to do that. It's another proportion. I'll give you a hint. It's another proportion. My second hint is what Isla said earlier. What did Isla say? 22.4 liters. Part of Avogadro's theory was this: 1 mole of any gas at STP occupies 22.4 liters of space. That's a constant. That doesn't change. And it doesn't matter what gas. Nitrogen, oxygen, helium, argon, carbon dioxide, doesn't matter. So that's a constant. You should now be able to answer it. We'll walk around and check it out. If we know 1 mole occupies 22.4 liters, then if we change the number of moles, we should be able to change the amount of space, or be able to figure out how much that volume changes. Time, I probably won't have anyone go up there. I'll just do it as a class. I thought I saw somebody. Well, I'm not going to run that out to you. I won't be here again today.
Why?
Because I gotta leave. I won't be here Friday either.
What are we doing?
I haven't figured that out yet. You're doing something today though.
Okay.
So it's
Who
your
left
two
out?
ones.
I don't know that either. I don't have a lot of answers, sorry.
44. Oh, I did it wrong. You have it right. I did it wrong.
Share. Share with your partners. Pair up. Share.
How'd you do?
Share with your
Can you
Gary.
see it?
Don't forget units. Shelby and Blake, let's go.
I did it wrong because what I did is I added these two, and then I forgot about the 11s.
25.
So 44 plus.
Sarah, you can talk to those guys. Charlie,
You are
help
right.
Sarah out. Or Sarah, help Charlie out.
I didn't do much. I went.
Yeah.
I
I forgot the 11.
Kayla, who are you talking
So
to?
it's just 1 mole equals over 22. So if I do 1 mole, you have to apply.
Oh, okay.
Yeah, I
Maybe
had
Shelby
it,
can.
but when he said you can do it proportion, I did it. And then you just 22 times 2.5.
There's a blank thing like that tape. I've seen it 2 days in a row. You see it? You see it?
It's the,
Yeah, I see it.
It's that means there's power over it. That's it.
Why is there tape?
You should get a new one.
Why is there tape?
That's like the one that's in my room. I have my Xbox hooked up to it. It's like so.
You have a tube TV?
Huh?
You have a tube TV? That's what that's called. A tube
Yeah,
TV.
but it's bigger than that.
Yeah, I know.
It's like a big
Like
one.
32 inch.
Yeah.
I think it is.
And then I have like a
It's
big
that
one
big.
downstairs.
The back of it sticks
Like
out
yeah,
like
like
that.
this big. Yeah.
You ever try to move that thing?
Yeah, I had to move it from downstairs.
No, because
My mom still has one from the 70s downstairs.
That's just probably
Like
I
I don't know. It's like a floor TV.
Yeah.
From like the
Oh, I know what
70s.
you're talking about.
It was like her first TV, and she still has it, and it still works.
That's cool.
And she still uses
All right, move back. Okay, who has an answer they'd like to share how they got it?
I just want to know about
Edwin does? All right. Straight up answer. Very good. 56 liters is correct. So Edwin, let's fill in our proportion. 1 mole of HE gas, good. 22.4 liters, good. So this being the constant, that's what he set up as his first proportion. There's 22.4 liters in 1 mole. Good job. Continue. 2.5 moles of HE gas. Good. X, right. So we know if you have 1 mole of HE gas, it occupies this much space. Well, what if you have more, right? You have 2.5. This number should be bigger than 22.4. How much bigger? 2.5 times bigger, right? Cross multiply, so X equals 56 liters. It's, hold on before you pack up, make a lot of noise. So it's kind of a random question, but it has to do with proportions, which is why I do it at the same time as the delta H. You can pack up, but keep your eyes up here. I'm going to keep talking until the bell rings. So Thursday,
Thursday.
after we go over the homework, we're going to talk about this equation. That's what you guys did yesterday in that classwork. Here's the thing. This C is a very, very important number. C is called the specific heat.
Thank you.
Now, so stay with me till the bell rings. Specific heat changes depending on the substance. So like aluminum has different specific heat than water, than the water that's in it. Let me give you an example. You ever been to an in-ground pool? Hopefully you have. There's concrete around it. In the middle of a summer day, really hot day. What's warmer? The concrete around the pool or the water?
Concrete.
Concrete. What about at night? Jake, stop talking, listen. If you were to go back in that pool at 10, 11 o'clock at night, the water would be warm. What about the concrete? It'd be cool. The reason that happens is this number. It's called specific heat. It's how fast something heats up and cools down, or how slow it heats up and cools down. Does anyone know why the concrete's hot during the day, but the water's cool during the day?
Because the sun.
What's that? Concrete has a high specific heat is what she said. You said because of the sun.
Well, you didn't let me say because I was gonna say that the sun heats up the concrete, And what happens
The
is
sun heats up the water.
yeah,
too,
yeah,
doesn't it?
yeah. But what happens is no. Listen. What happens is it takes the liquid longer to cool
So
down.
the water-
So it heats up, but it's not. It's still heat.
So the water heats up slower.
It's
we all
still,
agree.
still, and then it's
But it
cooled down
cools
at
down
nighttime.
slower.
It cools down at
But the
nighttime.
concrete cools down faster.
Yeah.
Confusing.
We'll talk more about it Thursday.
No, what happens is the concrete gets heated up by the sun, right? And then it gets hotter fast. And then the water gets still cool from the nighttime. And then
The water's cool from the winter time.
the nighttime.
I thought you said winter time.
Yeah, it's still cold